Hi, Donovan Keith here, and in this video I want to walk through how I would use C-Nodes in Cinema 4D 2024.5.1 to recursively subdivide something with triangles. So as I often do, I find it helpful to kind of mock something up with real geometry first. So what I'm imagining is something like this. We've got some sort of a null or an input object. I'm going to go ahead and add a spherical size here. Let's set that size to, I don't know, 100. And any polygon that falls inside of this sphere should get subdivided triangularly, I'm going to say. So I'm going to come in here and I'm going to just sort of mock up by selecting polygons whose centers fall within this, this sphere. And we can choose if any of their points do, but it'll be easier if we say those that definitely fall inside. And then I'm going to use the Poke Polygon command. So if I right click and choose Poke Polygons, that's going to convert my quads into triangles and my triangles into smaller triangles. Now let's also say that this actually is going to have a set number of iterations. So we will continue subdividing up until that maximum number of iterations, fading off from the edges of our sort of sphere here. So those in the center are going to get subdivided the most. So maybe we get something that kind of looks like this, maybe, not totally certain. And then this is going to get poked again. So where is our poke polygons? Poke that again. And then, oh, this one is right in the center for that very next iteration. We are going to poke those polygons again. And maybe we've got a really high iteration count and we're going to poke these polygons. So you end up with something that looks kind of like this based on this sort of input null and its positioning. And I'm going to give it a custom color, maybe like bright green, so it's just easier to see. And we can go from there. So now we've got our sphere sort of subdividing these polygons. So that's the basic operation that we're going to want to go through. Again, we are figuring out where this subdivision target is, let's say. We're figuring out if a polygon is inside of that or not. And we are going to repeat this operation over and over again. And if we're being really clever, we will add in a falloff based on the distance from the center, with this sort of being an outer distance. Maybe we'll have an inner distance. So how would I go about doing that? Well, I would first add a Nodes Modifier, which you can do by searching for Nodes Modifier, and then dragging that under your plane. Now, I've already got that because I wanted to have this text here, so I'm just going to add that in. It's turned on. And by default, oh my goodness, everything has already disappeared. So what I want to do is grab my geometry and wire it to the output. So now something has happened. And the plane, I'm actually going to start with a new default plane because I don't want to deal with all of those subdivisions. And rather than using a null, I guess we could use a null. We could just make it a child here of this to sort of visualize the position of the Nodes Modifier. But I'm actually going to use the Nodes Modifier itself as the center of my sort of fall off sphere here. So I've got my plane, I've got my Nodes Modifier, and then I kind of want to map out what I'm going to do. So it might be helpful to add comments to sort of plan out what you're doing. So here I'm going to hit Command / to add a comment. And my first goal here is to get all polygons. And then I want to, for each subdivision, maybe we can do this for each so for each subdivision, get all polygons. Once I've got all of my polygons, I'm going to test if inside, target radius, let's say. And we can say if inside subdivide. So we get something like this. And I'm also going to turn off notifications here because I just have a sneaking suspicion that I'm going to get some interruptions. So I've got my recursive triangle subdivision, and I'm going to be doing something like this. And then we subdivide, and maybe we can do, some sort of task like if in 0 to 1 range, modulate subdivision depth or strength, which is a fancy way of saying I don't quite know what we're going to do there yet, so I used a word that I barely understand. Okay, so we've got for each subdivision, get all polygons. If radius, if we're inside the target radius, do something and go from there. So let's just break this down one by one. So for each subdivision, what I want to do is have a maximum count for my subdivision. So I'm going to go to IO int for integer, and we see integer count, and then integer subdivision slider. I'm going to drag in my integer subdivision slider, and this is just a slider for a basic number, 0, 1, 2, but it's got an upper limit of around 4 because subdivisions can get really nasty with really high values, so that by default we're sort of limiting the amount of danger that we can get ourselves into, which is nice right here. And we'll just start with, let's say, 2 as our starting value. So if we want to do something, for each subdivision, what we can then do is drag out this subdivision value, rename this subdivision. This is our max count. We can even call this max subdivisions. I'm just going to copy that name. There we go. So we've got our max subdivisions. I'm going to use a range, which is the node that we use for this sort of iteration or looping. So I'm going to add a range node. I'm going to set my max subdivisions here to end. And so now this is going to be counting 0, 1, 2, 3, 4, 5 until it gets up to just before max subdivisions. So max subdivisions is currently 2, so it's going to go 0, 1, 2 is too high. We're not going to go to 2. So we would get 0 and 1 as the output of our range. The next thing we want to do is perform a recursive operation to our geometry. So when I say that something is recursive, it's just saying you're going to do a thing, take the result of what you've just done, and then do it all over again. So recursive is like a snake that's eating its own tail, except it's sort of eating its own tail and then eating its tail again, sort of over and over again. If you've ever heard the phrase Stack Overflow, I'm going to probably teach you some bad computer science because I'm not certain here, but I believe that is when you've just recursed too many times. An operation is tried to do the same thing too many times. Or at least that's a very good way to trigger that error I've found. So now I've got my range. I now want to do something over and over again. And for that, I need the loop carried value. And that's something you bring in when the previous result is important to you, and you want the result of that to be used again. So that's what the loop carried value does. And what I want to bring in here is my geometry object. So my geometry object, I can call this, let's call it mesh. And let's see, we've got our geometry coming in. I am going to use a connect object here. And the connect, I'm just going to say, force this to be a mesh, right? Like I'm only going to accept a mesh as an input, and otherwise, don't pass anything through. This isn't going to do anything special if you get a spline, except like you'll get no result, but that's better than getting an error. So now I've got my mesh that's coming in, and I want to drive this loop carried value with my scope that's coming out of this, which is basically the sort of like the hot wire of electricity. Like the current is flowing, the looping is happening because we're driving this loop carried value with this range. And the range we can drive in here, we can drop that in, and you can think of this as subdivision count or subdivision index. And the next thing we want to do is to bring in the local position that we're trying to measure relative from. Our local modifier matrix right here, I believe if you were to multiply by this, your geometry would get into modifier space. Let's not get too clever yet, but well, let's try it. I'm not certain on the matrix math here, so we might have to make some revisions. But what I'm going to do is I'm going to bring out my local modifier matrix. I'm going to call this modifier matrix. And from here, there's really only one thing that we care about, which is this translation. So I'm going to pipe this out and call this modifier position. And I believe that this is measured relative to our input geometry. And this loop carried value, I'm going to rename it Recursive Subdivision. And I'm going to output this. Now we get an error, and it's saying, don't know what exactly, but I can pretty much guarantee it's because we haven't actually stuffed anything inside of here yet. So I'm going to take my previous mesh, pipe it into my output, and now nothing has happened. So let's mock this up, right? Like with just doing a subdivision on every single polygon all the time. So I'm just going to add a subdivide node. And that subdivide node, I'm going to set my selection string to all. And it's going to subdivide all of my polygons as many times as this is happening. So I can set it to 0, I can set it to 1, I can set it to 2, and that's just going to increase the depth of subdivisions. So now I want to adjust the strength with which this is happening based on the distance from the position of my nodes modifier. And this is sort of represented with the subdivision target. So I can, I believe, just measure the distance between a polygon center and this modifier matrix that's coming in. And let's just do a simple test and say, are you less than 100 units away? If so, subdivide. If you're more than 100 units away, we don't subdivide you. So what I'm going to do is select polygons based on distance. And for that, select dist. Okay, there's not a distance-based selection. Is there a select sphere? No. So we're going to have to make our own selection. And for that, I'm going to use this nodes selection right here. I'm going to drag that on. And this is just an empty group for me to make my own selection. It's honestly the same thing as any other kind of nodes modifier. It's just a cute name for it. But I'm going to say select within sphere. And inside of here, I'm going to add a couple of outputs. I'm going to type IO position, or IO point maybe? IO vector. There we are. IO vector, this first one, I will call position. I'm now going to add a size, IO size. And this is my radius. And we can even call this outer radius. And now my position, I want to measure that against the polygons in my geometry. So I'm going to get a poly info, polygons info. And from here, we've got a list of polygon centers. So we're going to test not whether every point of a polygon is inside of our sphere, but we're just going to simply ask, hey, is the center of our polygon inside of the sphere? So now I've got my centers. I'm going to do an distance. Yeah, okay. Let's do an iterate collection. So we're going to go through every single center. We see that we have created this ... here, which is the start of trouble. And what we want to do is to calculate the distance between a given polygon center and the position input of this array, or of this this selection modifier. So I'm going to drag out position. I'm going to type position here. And now I'm going to add a couple nodes, or I'm going to add a node called distance. And here I have distance. I can just do like so. And I can now do a range mapper and say that my distance is what's coming in. My input max is my outer radius. Or actually, my input minimum is my outer radius, and my input max is 0, which is to say Values at the edge of the sphere, they've got a strength of 0, and values at the center of our sphere have a strength of 1. And you know what? Actually, I don't even need to do that. Let's just do a simple Boolean here. So less than, so I can say if the distance is less than or equal to the outer radius, then this means that we want to select. And I can choose to a symbol collection. I'm going to be assembling an array. So a set of Boolean values, replace basic bool of true, false values of whether or not something is selected here. I'm connecting this open scope to this one so we don't create a problem where we're creating a bunch of things. And I'm now going to use my select node in polygons mode. And I'm going to choose as an input, inputs, selection. And selection will accept, I believe, oh, it does not accept this type. It doesn't accept an array of Boolean. So what I'm going to do is create an array of indexes, because that's what it's looking for, is an index selection. So I can get rid of this. I'm going to do an symbol collection, or let's do an append elements. And I'm going to append Boolean values. And I want to turn this into an array. So I'm going to choose insert above array. So now I've got an array of Booleans. Again, we're driving it with this right here. Excuse me, not an array of Booleans, an array of integers, excuse me, because we're trying to append the indexes. This is the index right here that we will be appending. And I want to choose how many elements I'm going to be appending. That's my count value. And I'm just going to use my Boolean to decide whether or not to append an element. And now I can use this as my selection. I can output this for my geometry. And this will select those polygons. So this doesn't look like much right now. My subdivide right now is selecting everything. But if I change this to active, it is only selecting these active polygons whose distance is less than this. That is surprising. Let's see what happens here as we adjust our maximum subdivisions. So at 0, nothing. At 1, it's selecting what's in the sphere. At 2, it's now selecting sort of things that are outside of this. So something is, I think, relying on our previous selection and leading to weird results. And I suspect it is our polygons info, which is using the selection string default rather than all. I wanted to iterate through all polygons and then decide what to do based on that. So now my recurse subdivision, if I increase the maximum here to, say, 3, we're going to get something kind of like this. So it is subdividing. And I want to feed the position with my modifier position. So now as I move this around, we're getting this result right here. Now, I want this to be a little bit cleaner than that. I don't want this to create quads. I want it to create tries. So rather than a regular subdivide node, I'm going to use the Poke Polygons node. And now we get something like this. And this is an improvement of a sort. Right, as I move this around, we're definitely getting this. But what I want is also to have an inner radius. So I want my subdivision index to adjust the sort of the maximum radius for my select within sphere. So let's go back outside here and let's adjust. Let's add a setting for our maximum radius. IO size, outer radius. Our outer radius comes in here. I'm going to pull it out. Call this outer radius. And now I want to pipe my outer radius into here. And let's also add an inner radius. IO size, inner radius. Let's drag that out. Inner radius as well. And let's pipe this in here. And max subdivisions, I'm also going to use this as an important sort of value as well. So I'm going to put this in, max subdivisions. Great. So what I want to do is somehow take the outer radius and shrink it towards the inner radius value. So we're selecting fewer and fewer things each time. As we go up by max subdivisions. So let's think about this. We want to go from outer to inner. If there's 2 subdivisions, 0 steps, 1 step. Okay, 3 subdivisions, 0 step, 1 step, 2 step. Okay, so max subdivisions, subtract 1. So subtracting 1. And then I want to divide this, my subdivision index by this. And now I want to do a range mapper. Using this, going from outer radius to input radius over time and feeding this in here. And now if we take a look at our inner radius and we set it to 0 or some smaller number, right? We've got an inner radius like so. And let's adjust our radii as well. I don't know that I'm really going to want this to go all the way out to like 1,000. Let's say maybe at most 500. And I'm just going to move these properties into the object tab so it feels a little bit cleaner. Let's default inner radius to 0. Whoops, excuse me, outer radius to 200 for 100, inner radius to 0. Max subdivisions, let's set that to 3 so we can really see some changes here. And maybe the maximum subdivisions to 5, which could get us in trouble with a dense enough mesh, but I think this is going to be okay. So now let's take a look at this. I've got my Nodes Modifier that I'm moving around. I don't really need this subdivision target anymore. This is my radial or recursive triangular subdivision. And let's see what happens as we move this around. And we are now getting something like this. It works reasonably well. Let's increase our settings and sort of jiggle it around. And if you wanted to do, sort of as an exercise for the viewer, if you want to get really clever, you can go in there and, ensure that the restriction is only the subdivision is only happening to that which has been previously subdivided, right? Because we're getting this sort of situation, right, at the edges here, where we've poked a polygon in one of the earlier steps, and then it gets subdivided. It can feel a little unpredictable, but I'd say this is generally feeling pretty good. And because we're using like real world sizes here with like meters, I can come in and use my scale and model mode and just sort of scale this interactively. And I will adjust my inner radius further and maybe crank this up to 4 and adjust my outer radius. And really, we've now got this really pretty sort of thing. And whoops, I accidentally created a text. And then if you want, I suppose, at the very end of all of this, you could poke one more time. And this last poke, let's do all. And you can choose to just move them up ever so slightly. And you get something like this. Or we could choose to have that movement in our poke on a per step basis. So I can take this offset, I'm going to move it out. I can take this offset, pipe it out as well. And this is now my push, let's say. I'm going to adjust my resource, move my push into here. And push is now a value that I can sort of tweak. So every single time I poke, I push a little bit. And so now if I increase my radius, my inner radius a bit, and maybe my total number of steps, and display garage shading. And let's turn off our angle limit here. Or excuse me, let's set our angle limit to 0. And let's see what happens when we put this on a more interesting surface, like a, I don't know, a platonic, for example. And now I can move this around, adjust my outer radius. And I get something like this. And I can, again, adjust the amount of poking. My outer radius, my inner radius, and there you go. That is how you might build a recursive triangular subdivision algorithm. Let me walk through it again really quickly. So you've got a high-level overview again, but we're, I think, basically following the map that we set out. We take our input geometry, and then for each subdivision, and that's why we're using range right here, we want to get all of our polygons, which we're doing inside with this select within sphere. So we're getting all of our polygons with the polygon info, getting all of them. We're going through all of our polygons, and then we're seeing, hey, are you within a certain distance? If so, create an array with the index of that polygon and select it at the end. Once we've got that, we're going to poke you. And we do that over and over again. And we also say we modulate the amount of subdivision based on this outer radius. And we're doing that inside of here with this range mapper, where we're just saying for every subdivision, you're sort of walking a little bit forward. How much subdivision should we be doing here? How many, how large is the maximum radius? It's getting smaller each iteration. Okay, so this may be a little bit shaggy because I was sort of thinking my way through this project as I was building it, but hopefully that's actually a little bit helpful to see the thought process for solving problems, rethinking things, and thinking about how to approach a thing as you are actively building it. And definitely, I would say, save a version of your file and have a play with it. I hope that that this is interesting and helpful. Okay, bye-bye.